In this video, I'll show you how the Bellman-Ford algorithm works using a straightforward example. Here's our graph. We have 7 nodes, S, A, B, C, D, E, and F. Our goal is to find the shortest path from node S to every other node. First, we'll set up a table to keep track of distances from S. Set the distance to S as 0. All other nodes start with a distance of infinity. We'll repeat the process 6 times, since there are 7 nodes. Let's do the first iteration. Start with S. From S, we can go to A with a cost of 5, and to F with a cost of 7. So, update the distances for A and F. Next, look at A. From A, we can go to C with a cost of 1. Update C to 6. Now check B. We don't have a path to B yet, so skip it. Move to C. From C, we can go to B with a cost of -1. Update B to 5. Check D. We still can't reach D, so skip. Now E. Even though E can reach D, we don't know how to get to E yet, so skip E. Finally, check F. From F, we can go to E with a cost of -2. Update E to 5. After the first round, some nodes might still be at infinity if there's no way to reach them yet. Let's do the second iteration. Start from the top again. The distances for S, A, B, C, and F stay the same. Now look at E. From E, we can go to D with a cost of 6. Update D to 11. Nothing new for F this round. Let's do the third iteration. Go through every node one more time. No distances get shorter. That means the algorithm can stop here. Now, the table shows the shortest paths from S to all other nodes. This is how the Bellman-Ford algorithm works. Thanks for watching.